So good morning friends. Today our problem is to find the GCD of two numbers. So today we are going to first see the brute force approach and then efficient approach and then more efficient approach. So how we will go through the approach? First let us start with the brute force approach. Before starting this approach, let me tell what is GCD and how to find the GCD in normal way. So GCD is the greatest common divisor, means among the two numbers, among the common divisors of the two numbers, what is the greatest number, then it becomes a GCD. For example, we will take 20 and 15. For example, among 1 to 20, among 1 to 15, 1, 2, 4 and 5 are the perfect divisors, perfectly divisible factors of 20, and then 1, 3, 5, 15 are the divisors of 15. Among those, the common divisors were 1 and 5. So among 1 and 5, the greatest divisor was 5, and this is GCD. So let me tell. So this is, in this way we can find the GCD of two numbers. But how we will convert into a program? So with minimum number of steps. So as we think the greatest common divisors, as we require 16, 17, 18, 19, 20, because the greatest common divisor which is divisible by the, which divides the both the numbers perfectly, means it's 16, 17, 18, 19, 20 divides 15? No. So cross these numbers. So in our program, let me tell you, we can first find the minimum number. So I think so 15. Now the second one thing is, going from starting of the number, let me go from the reverse loop, from the reverse 15, 14, as it is a greatest numbers are always reside in last, right? So let me start from a minimum number, that means for example 15, 14, 13. So the greatest, instead of going in this way, let me go in this way to reduce the complexity for bigger numbers. So let me go through this approach. So first we have to find the minimum number for deleting the remaining numbers. So firstly let me find the minimum number. If a less than b, then minimum a. So in this way we find the minimum number and then go through the loop. First int I is equal to minimum and go up to 1 and then I minus. So if anything perfectly divides both the numbers a and b, then print that number. There is a one greatest common divisor and print that number and break from the loop. So this is the approach. Let me tell what is the time complexity of this. The worst case, in the worst case, so it will iterate min to 1. So minimum number of times as the asymptotic notation, order of min of a comma b. So let me tell you, this is efficient. Okay, then if we have large prime, for example if there are prime numbers 1733, like 1333, so minimum number is 133, so it will iterate for 133 times, which is not at all efficient. The prime numbers for the GCD for prime numbers, both prime numbers is always 1, right? So it will iterate 133 times. The loop doesn't break. If up to 1 the loop doesn't break, at 1 it breaks, other than it doesn't break. So this is somewhat very crucial. So this is the worst case complexity, worst case time complexity. So let me, so Euclid's, so one scientist known as Euclid's solve this in a very efficient way. Let me try this. So coming to Euclid's, let me take the same example 15 and 20. He takes a maximum number and replaces it with the difference of the max and min number, and next he continues the same procedure and he takes the maximum number again and he replaced the maximum number with the difference of the two numbers. So replace max. Again he continues the same process. Here the maximum number is 10, difference of is 5, and replace the maximum number with 5. So he continues this approach until the both the numbers are equal, until the both the numbers are same. Then he returns, he defined it as a GST. We can return anything, it is A or B, both are same. So how to find this? So first we have to find this loop iterate. So we take a while loop, right? So this loop iterate until or unless both the numbers are equal. So while A not equal to B, if A greater than B, then do max difference between the max and min number and replace with the maximum number with this difference, else. So this is the approach. Let me see what is the time complexity. Time complexity means it is a very efficient. So here in the last approach, uh, to find the 15 and 20 using brute force approach, it will take 10 steps or 10 steps, but using Euclid's it will reduce it to 3 steps. It is very efficient, but in some crucial worst case conditions it will take more time. What are those worst case conditions? Its time complexity is order of max of A comma B. So let me see what is the time complexity. For example, if you take any 13 and 1, if you take any prime number and with 1, then 13 minus 1, 12, replace the max number with 12. 12 minus 1, 11, replace the max number with 11. So this approach continues until both the numbers are 1. So is this an efficient approach? So I will say no. The greatest common divisor between the prime numbers is 1. Is this efficient? It will take 13 times that the order of complexity. In worst case is order of max of A comma B. So one more scientist, based on the Euclid's algorithm, tells more efficient approach. Let me see those approach. So same example 2015. In before algorithm we will take the difference, but here we calculating the remainder. So and replace the max with that remainder. First find the max number and then replace that, calculate the remainder and replace the max number with remainder. So here max number is 20, 20% 15 is equal to 5, and replace the max with 5, and again calculate 15% 5 and replace the 15 with 5. So here the remainder becomes 0. 15% 5 is equal to 0. So replace the max with 0. So when any one of the value becomes 0, then terminate the loop and return the non-zero number. So return the GCD which is non-zero number. So here it automatically. So why it is efficient? Let me see. It will also take 3 steps. So let me take the worst case approach in before. 13 and 1. 13% 1 is 0. So it takes just 2 steps. So it will return GCD in 1. Very efficient, right? So how can we go the approach? So we will iterate the loop until or unless A equal to 0 and B not equal to 0. So A or